this video, I'm going to talk about the principles of statics. And in statics, we need to know what a force is. What is a force? A force is a mechanical interaction between bodies that changes or tends to change the state of motion of the body or changes the shape. So we know what a force is. Now we're going to break it down into two different groups. We have the reactive force and the applied force. What is a reactive force? A reactive force, it is a force that is exerted on the body by the supports to which it is attached to. And an applied force, these are forces that are acting on the body that are not provided by the supports of the body. So I'm going to talk much about the reactive forces. So let's discuss the reacting forces. What are reacting forces? We know what reacting forces are, and we're going to break them down into three categories. So we're going to have the first category, which are the supports with one unknown force, and these include cables, rollers, frictionless surfaces. And in the second category, these are supports with two unknown forces, which are the pin support and hinge support. Then in the last category, which is the third, we have supports with three unknowns, which are the built-in supports. Okay, so we know the three groups of reacting forces, which are one with the one unknown force, the second with two unknown forces, and the third with three unknown forces. Okay, so let's get in detail of each of these categories. So we're going to start in the first category, which are the cables. For example, we have been given this simple body, and we know that the reacting forces in cables, we only have one unknown. So if we were taught to draw the free body diagram, what would it look like? Okay, let's see what the free body diagram of a cable support will be. So this will be the free body diagram, whereby here that's where we're going to have our reacting force, which is the tensor force. So here we have our theta and our theta, and here the free body diagram, here this will be our reacting force. Let's go to rollers. Rollers, for example, I've been given this one and this one. The two, they are all roller supports, but a bit different. So for rollers, we need to have it in mind that the reacting forces are always perpendicular to the surface. So our reacting force will be perpendicular to the surface. Same with this one. Our reacting force is going to be perpendicular to the surface. So our free body diagram for this will be something like this, whereby this reacting force is perpendicular to the surface. And same here, the reacting force here is perpendicular to the surface. Then we have the frictionless surface, where we're going to use rockers in this case. So we have our rocker here, and for rockers to frictionless surfaces, we need to know that the reacting force will always be perpendicular to the surface. So what will be our free body diagram for this? So our free body diagram will look something like this. So we know that this is our surface, and our reacting force is always perpendicular to the surface. So this will be our reacting force. So for rollers and frictionless surfaces, we need to have it in mind that our reacting force is always perpendicular to the surface. So we come to conclude that in the first category, which is the cables, rollers, and frictionless surfaces, we only have one unknown reacting force. Let's move on to the second category. In the second, which is the pin support or the hinge support. So in the second category, we have been given something like this that we can use as an example. Our reacting force for this, in the second category, we know that there will be two reacting forces. So what will be our free body diagram for this? So our free body diagram will be something like this, we're going to have a reacting force in the y-axis and the reacting force in the x-axis. So same with this one, we're also going to have the reacting force in the y-axis and the reacting force in the x-axis. So we're going to have reacting force y and reacting force x. Same here, reacting force y and the reacting force x. So we need to come to conclude that whenever we're given a pin support or the hinge support, we need to know that it will have two unknowns, which are the forces in the y and the forces in the x. Let's move on to the third category. In the third category, where we have our built-in support. For example, we have been given this built-in support. What will be our free body diagram for this? Our free body diagram for this will be something like this. We're going to have the reacting force in the y-axis, the reacting force in the x-axis, and we're going to have a couple. We're going to have a couple. So we have 1, 2, 3. Reacting force y, reacting force x, and a couple. So we'll come to conclude that supports in the third category, which are the built-in support, they have three unknown forces, three unknowns. We'll come to conclude that supports in the third category, they have the three unknowns, which are the reacting force y, reacting force x, and the couple. In summary, we can use this to quickly know about this. We have categories 1, 2, 3, and number of unknowns. We have 1, which is the first category, 2 for the second category, 3 for the third category. Then the type of support, we have rollers, rockers, link. This one we talked about. This is in the first category, so we need to know that we have one unknown force. Then the hinge support is in the second. Since it's in the second, we're going to have two reacting forces. In the third category, we have our fixed. So since it's in the third category, we're going to know that it has three unknowns. So this will be so useful as we start to do, as we start drawing the free body diagrams. Thank you for watching. Don't forget to subscribe and to like the video.